Hello guys, welcome to Introduction to NumPy. In this tutorial, I will teach you how to use NumPy and how to use it for data analysis. So please do watch the video till end. First of all, NumPy stands for numerical Python. Okay, now you must be thinking why use NumPy? So the advantages of using NumPy are, the first and the major advantage is NumPy is 50 times faster than list or array. Then it has lots of supporting functions, so it gives many supporting functions that are used for data analysis. Then NumPy arrays are stored at one continuous place and so can access them efficiently, performance, and they are written in C and C++ for faster performance also. Also, if you want to see the code for NumPy, then it is available at GitHub repository. So these were the advantages. Okay, so now let's see how to install NumPy. Go to File Explorer, then go to C drive, then go to Users, go to your name, then go to App Data, then go to Local, then go to Programs. Where is it? Yeah, Programs. Then go to Python, then go to Python 3832. So versions may differ. Now go to Script. Okay, now copy this address and then open CMD or command prompt, then write cd space, paste it over here and enter. And now just write pip space install space numpy. So it will install NumPy for you. I already have it, so it is showing requirement already satisfied. Now after NumPy is installed, again write pip install Matplotlib. So we will be needing this library also, and give it an enter. It will install it for you. I already have that library, so it is showing requirement already satisfied. After installing, just close it, and now I will show you how to import the library. So importing the library, import NumPy as NP. This statement should be written at the top of your code every time. So this will import the library in your code, and also as is used to give an alias name. So as keyword is used to give an alias name. In simple language, alias name in Python means alternate name. So I can call it as NumPy or as NP, both. So this was all about installing. Okay, now let's talk about arrays in NumPy. Creating arrays. So first we will see how to create a 0D array. So first, don't forget to import NumPy or import library inside your shell. So import NumPy as NP. Now we will create a 0D array. Pass constant value. For 1D array, make a square bracket and inside that pass values separated by comma. For making a 2D array, make a larger square bracket and inside that pass two 1D arrays. So I am copying this. The values can be different, but just separate those 1D array with a comma. Then for 3D array, yet more larger square bracket and inside that pass two 2D arrays separated by a comma. Values can differ. For multidimensional array, we use a function named ndmin. So first, pass the values inside any array 1D, 2D or 3D. Then write ndmin equals 9. So that will create a 9D array. So let me print all of them. This is a constant value. Print x, 1D array, print y, 2D array, print z, 3D array, print, this would be interesting, a. This is a 9D array. There are 9 square brackets, and inside those 9 square brackets the values are situated. Okay, we can check the dimensions using ndim. n dimension or n dim. So x dot n dim will give you the dimension of x, y dot n dim will give you the dimension of y, z dot n dim dimension of z, and a dot n dim will give you dimension of a. Also w dot n dim will give you dimension of w. Now moving on, so this is what I taught you. Moving on to indexing. For 1D array, the indexing is similar to list. So 1 is 0, 2 is 1, 3 is 2, and 4 is 3. And for negative, starts with 4 and decrements till the first index. And accessing elements is similar to list. Now let's see for 2D array. For 2D array, there are two 1D arrays situated inside. So there are, first we will have to access the 1D array. So the bracket has index 0 and this bracket has 1. So if we want to, then first we will access the bracket. So bracket number is 0, and then inside that bracket 2 is on the first index. So this will give us 2. For 3, bracket number is 1 and 3 is on index position 0. This will give us 3. For negative indexing, just remember how to find the positive index and subtract the number of elements present inside the 1D array. So here 2 elements are present. So just subtract 2 and you will get the answer. So 0 minus 2 is minus 2, 0 minus 2 is minus 2. So first for 1, minus 2 comma minus 2. For 0 comma 1, minus 2 comma minus 1. So it will give us 2, and so on. For 3D array, we will have 3 index. First, there are 2 2D arrays. So the first 2D array is 0 and the second is 1. Then inside that there are 2 1D array. So the first 1D array is 0 and the second 1D array is 1. Here also 0 and 1. Inside that, give the index position of the number. So for 3, we have to write 0 comma 1 comma 0. 0 is the 2D array position, 1 is the 1D array bracket number, and 0 is 3 inside that 1D array. So this will return 3. So these are the values of indexing. And for negative indexing, there are 2 elements in each and every 1D array. So subtract 2. Do it yourself. And please try it inside in the shell. Practice for this. It is important. Moving on to slicing. Slicing is also similar to list. This and iterative slicing. This is normal slicing, this is iterative slicing. So we will take an example of this 3D array. X equals array, np.array Now we will access both brackets but just the index number 1. So we will access 2 and 5. So it will return an array of 2 and 5 because the first index position gives the index of the bracket, as I told you before. So for 0 colon 2 will give 2 is not included inside that. So 0 and 1. So 0th bracket and first bracket. Inside those, we are accessing the one index number. So the one index number position is situated by 2 and 5. Now if we give only the first bracket, so one index bracket, so 0 and 1. So this is 0, this is 1, and we give 0 colon 2. So it will give us 4 and 5 because 2 is not included. So 0 and 1 are returned from the first one index bracket. Now if we write colon colon minus 1 is used for reversing the array in both, then it will reverse the whole array. If you want just the second bracket, then write x1 comma colon colon minus 1. So it is the second bracket reversed, or second 2D array reversed. So this was all about slicing. You can try this again. Now comes data type. It has all the default Python data types, but also has more. So these are some of the more data types: integer, boolean, unsigned integer, float, complex float, and so on. You can set the data type. And D type, you can check the set data type of an array. So this is a array, np.array, and we have defined the data type as i4. So what is i4? I1 means integer 4 or length 4 bit. I2 means 8 bit, 16 bit for 3 and 32 bit for 4. So if I write like this, array equals np.array 1 comma 2 comma 3 comma 4 comma d type equals I4, and if I check dot d type, array dot d type, then it will say integer 32, because I4 is used for integer 32. So this was all about data types. Okay, so this was all about arrays. Okay, now let's talk about copy and view. Copy method will create two independent arrays, and changing the original won't affect the copy. So we will use this code to check it. First we will create an original array, then we will copy it into X, and then we will change the original array index 0 from 1 to 21, and then we will print both array to check if it is changed or not. So first import numpy as np, then array equals np.array, so arr equals np.array 1 comma 2 comma 3 comma 4 comma 5. Now x equal array dot copy. Now array 0th index equal 21, print x 1 2 3 4 5 and print. So changing the original did not affect the copy. Now moving on to view. So view method will also make a copy, but changing the original will change the copied array. So let us prove using this again. So first we'll define an array and x dot view, x equal array dot view. Now array of 0 equal 21. So print array 21 and print x, that also 21. So changing the original did change the copied version. So this is the difference between copy and view. Moving on to base, to check if the data in the array is its own data or not. So this will return none if it is its own data, and it will return an array if it is not its own data. So for example, let us again define this array. X equal copy 1 and y equal array dot view. Now print x dot base None, because it is original. Copy will create an original array and print y dot base. It will print an array. So this is not original. So this data is not its own. So changing the original will change this values. Okay, so this was all about copy and view. Okay, now let's talk about shape and reshape. First, shape. NumPy arrays have an attribute called shape that returns a tuple with each index having the number of corresponding elements. For example, if we take a 2D array, it has two 1D arrays. So this is the first one and this is the second one. And inside those 1D array, there are 4 elements each. So it will return two 1D arrays, so 2, 4. So 4 elements each. So it will return 2, 4. Then if we take an example of this 3D array, there are two 2D arrays first. So these are the two 2D arrays. Then two 1D array inside those 2D arrays. So first two 2D array, then two 1D array. And inside those 1D arrays, there are 1, 2 and 3 elements. So 3 elements inside that. So it will return 2, 2, 3. Let me remove the marker. Yeah, it will return 2, 2, 3. So let me show you in the shell. So x dot shape will give 2, 2, 3. So this is what shape is. Moving on to reshape. Reshaping means changing the shape of an array. The shape of an array is the number of elements in each dimension. By reshaping, we can add or remove dimensions or change number of elements in each dimension. For example, if we take this 1D array and we change it from 1D to 2D using reshape. So let me make a 1D array, np.array 1, 2, 3. So this is a 1D array of 12 elements. So now x dot reshape 4, 3 would give 4 1D arrays with 3 elements each inside a 2D array. So if I write x dot reshape 3, then it will give 3 1D arrays with 4 elements each. If I give x dot reshape 2, 6, then it will give 2 1D arrays with 6 elements each. But remember that the multiplication of these elements, these numbers should be 12 always. You cannot just enter any random numbers and it will reshape into that. Okay, now let's go for 1D to 3D. So we will give it x dot reshape 2, 2, 3. It will give two 2D arrays, and inside those two 2D arrays there will be two 1D array, and inside that 1D array there will be 3 elements each. So x dot reshape 2, 3, 2. Now let's give this. So there will be 3 1D arrays inside 2D arrays, and each will have 2 elements each. So this is what reshape is. So I told you that multiplication of all numbers should be 12 always. So this 4 3s are 3 4s are 2 into 2 into 3, 6 2s are all are 12. So you cannot reshape into any possible combination. It should be feasible. Okay, for unknown dimension, you are allowed to have one unknown dimension, pass -1 as the argument, and NumPy will calculate for you. For example, x dot reshape 2, 3, -1 will give the same output. So it will basically calculate for you. So this is unknown dimensions. So this was all about shape and reshape. Okay, so this is an important part, statistical functions in NumPy. So the first is amin and amax. These functions return the minimum and maximum from the elements in the given array along the specified axis. So you must be thinking, what is a specified axis? So you need to remember that x is equal 1 for row and x is equal 0 for column. If you want to pass a function row wise in an array, then you need to give x is equal 1, and if you want to pass function column wise in an array, then you need to give x is equal to 0. Okay, now moving on to a min and a max. Let us suppose that a is a 2D array and we are performing a min and a max on that. We will see all the possible outcomes. So np.amin, so here my array is a, so we will first find the minimum of all arrays, so it is 2. Then mp.amin for, okay, now we will find row wise. So row wise 3 and 2 is the minimum. Yes, 3 3 2. Now let's see column wise. So column wise means 3 8 and 2 minimum is 2, 7 4 and 4 minimum is 4, 5 3 and 9 minimum is 3. So 2 comma 4 comma 3. Now let's see np.amax of a, it should be 9. np.amax of a comma 1, so this is row wise 7 8 and 9, and np.amax column wise 8 7 and 9, so 8 7 and 9. So that is column wise. This was all about a min and a max. Moving on to PTP. PTP function returns the range, so maximum minus minimum of values along an axis. So let's take this the same array and we'll see all the possible outcomes. np.ptp of a, so maximum of a is 9 and minimum of a is 2, so 9 minus 2 is 7. np.ptp of a comma row wise, so 4 5 and 7. So row wise 7 is maximum and 3 is minimum, so 7 minus 3 4, 8 is maximum, 3 is minimum, 8 minus 3 5, and 9 is maximum, 2 is minimum, 9 minus 2 7. Dot ptp a comma 0, so this is the answer column wise. So moving on to percentile. So it has 3 arguments. The first one is array, the second one is percentile to compute, it should be between 0 to 100, and the third one is axis, either row or column, 0 or 1. So let's take this array, so that is the B array. So np dot percentile of whole array, okay, sorry, I said there are 3 arguments and I have just put one argument, b dot 50. So this is the answer of whole array in general, b comma 50 comma now row wise. So this is the answer, and np dot percentile column wise would be b comma 50 comma 0. So this is the answer for column wise. Moving on to median. Median is defined as the value separating the higher half of a data sample from the lower half. So let's take this example and compute the median in all possible forms. So it is C array in my shell. So np dot median, in general, what is the median? 65. Now np dot median row wise c comma 1, this is the median for row wise, and np dot median column wise c comma 0. So this is the median column wise. Okay, moving on to mean. Arithmetic mean is the sum of elements along an axis divided by number of elements. So let's take this example and find the mean in all possible forms. So np dot mean d, let's find the general mean, it is 3.666. np dot mean d comma 1, row wise it's 2, 4 and 5. np dot mean d comma 0, column wise it is 2.6, 3.6 and 4.6. Okay, so this was all about mean. Moving on to average. Weighted average is an average resulting from the multiplication of each component by a factor of reflecting its importance. So if you don't give weights, then it will just compute the average, normal average. So first let's see the normal average. Average, spelling is wrong. Average of E in general is 2.5. Now let's take a weighted average. So E comma weights should be defined as, okay, I define it as 4 comma 3 comma 2 comma 1, and then comma, to return the sum of weights you need to write returned equals true and enter. So this is the average, weighted average, and this is the sum of the weights. So moving on to standard deviation and variance. So to calculate standard deviation, just type np.std. So we will find the standard deviation of E array, which is same as 1, 2, 3, 4. So the answer is 1.118. And to calculate variance, it is np.var. So np.var of E, the answer is 1.25. Okay, so this was all about important statistical functions. Okay, so this is the most exciting and interesting part of NumPy, Matplotlib. I won't bore you with the introduction. If you want to read it, please pause the video. So import the package. From Matplotlib, import PiPlot as PLT. So PiPlot is the most important function of Matplotlib. So what is PiPlot? It is used to plot 2D data. So let us take an example of this code. So here first line is x equals np dot a range 1 comma 11. So this is equivalent to range in Python. So basically it will give a range from 1 to 10 because 11 is not included. And now y equals 2x plus 5. So this is the equation of a line. So this is the equation of a line. And then plt.title, this will give the title to the plot. Then x label will give the caption to x-axis. Y label will give caption to y-axis. And plt.plot will plot the graph, but it won't show until you call the function plt.show. So it won't show it. Let me show you in the shell what happens. So pyplot and run module. So this screen will appear, and this is the pyplot and the matplotlib demo. So this is the title of the graph, this is the y-axis caption, and this is the x-axis caption. And as you can see, there is a default blue color line for the plot. Okay, let me come on that now. Moving on to markers. So the default was solid line style for marker. So you can change it to anything you want. There are 26 markers. I have only shown 8 most important and most frequently used markers. And color. So these are the available colors, and these are the code for the colors. So these are the codes, character code for the corresponding colors. So the default was blue. Now let us see a program using markers and colors changed. So the program is one and the same, but when you write plt.plot x comma y, you will add another argument comma o and b. So o is, let us go back to markers. So O is the circle marker, okay, and G is green for green. So OB means, okay, so B is the blue color, okay, not green, it is blue color. So basically you need to give a marker and marker code and then color code. So if I give dash dash B, then it will print a double dashed line with blue color. If I give dash dash G, then it will print double dashed line with green color. Okay, let's see this. Okay, just okay, now run it. So there is our circle marker with blue color. Okay, so this was okay. Let us change it and keep dash dash and save and run it. So there is our dash dash line with blue color. So this is how you change the default. Moving on to subplot. What is subplot? The subplot function allows you to plot different things in the same figure. So in the same video you can plot different things. Okay, now let's start with x equals np.arange. From 0 to 3, this npy dot pi is the exact value of pi. So this is, it is basically this 3 star pi, comma 0.1. So 0.1 is the step, so it will include 0.1, 0.2, 0.3 and so on till 3 pi. So this, so more the value, the less the step, the more the smooth curve it is. Okay, so we are plotting sine and cos functions in the same window. So y underscore sine equals np dot sine of x and y underscore cos equals np dot cos of y. So basically that is y equals sine x and y equals cos x, just two different names. Then plt dot subplot 2 comma 1. So 2 is basically the column. So our current orientation is first plot and then second plot. If you want to change like this, then you give 1 comma 2. So there will be one row. So this is one row, but there will be two columns. So this is how rows, columns and then number. So 2 comma 1 and then this is the first plot. So first plot is plt dot plot x comma y underscore sine. Then title is sine. Then plt dot subplot 2 comma 2 comma 2. So this is the second plot. So that is y underscore cos and title is cosine. And then show it. Let me show you subplot. So this is how it will look like, sine and cos in the same window. Okay, so this was all about subplot. Sorry. Okay, now comes bar. So bar graph. The PiPlot submodule provides bar function to generate bar graphs also. So this is a program to find bar graph. So x and y are one of the functions and x2 and y2 are another. So we will plot plt.bar with x comma y first and with x2 comma y2. So the default color would be blue, and so we will change the color to green like this. So we will color equals, the color code is G, and there will be one more argument here, align equals center. So it will be center aligned, and plt dot title is bar graph, plt dot y label is y axis and plt dot x label is x axis, and show. So basically x and y will be plotted and x2 and y2 will be plotted. So control open and bar graph. Okay, let me run it. So this is our bar graph. So there are 3 values for each, so there will be 6 lines. Moving on to histogram. NumPy.histogram function takes the input array and bins as 2 parameters. So there are 2 parameters. The successive elements in bin array act as the boundary of each bin. So for example, if we have taken 0, 2, 20, 40, then the first bar would be from 0 to 20 and the second would be 20 to 40. So like this and like this, continuous bars. So and a equals, this is the array, 1D array with values, so it should be 1D, okay. And plt.hist will take a comma bins equals this. So bins equal, give the value of the range you want in the histogram. So here I have taken it 0, 20, 40, 60, 80, 100, and title would be histogram. So let me show you. Control open and histogram, run module. Here this is our histogram. So as you can see, it is continuous. Okay, so this was all about Matplot library, and this is the end of our session of NumPy. So I hope you like it. Please like, share and subscribe my channel. Thank you guys for watching.